Are you guys doing okay? Ready to start the class?
Ready.
Alright. Tapi I need to point some. I don't know why I need to admit this manually. Maybe those who I appoint as the host or co-host can help me to admit your friend. Alright, again, blank screen. One thing I don't like about online session is it's not interactive at all. But we got no choice. Shall we start?
Yes,
Doctor.
Yes.
Yes, Doctor.
Okay, 86 of you here. Can you see the slide?
Yes.
Yes.
Okay. Can you see it in full screen?
No.
No.
Okay, how to make it full screen? Crazy lah. It's been some time since I used Zoom to teach. Let me check. Can you guys see it in the full screen?
Yes.
Very good. Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good evening. Alright, so now we are in the second week. Please let me know if you guys cannot hear me or maybe cannot see me. It's fine that if you cannot see me. The most important thing is you guys can hear or listen to what I'm saying. Okay? Alright, so for those who are appointed as the host, please help me to admit your friends. Okay, can you do that for the host? Hello, can you guys hear me?
Yes.
Doctor, is it me, the host?
Yeah.
I just realized. Oh, I already admitted.
I cannot even see you guys. Okay, alright. Wait, yeah. Because I'm using two screens, so I want the main screen to be. I want the slides to be in the main screen. It's very realistic. Give me some time to sort this out. Yeah, I think I'm just gonna use one screen. Yeah. Okay. Share. Okay, can you guys see the slide?
Yes.
Can you guys see it in full screen?
No.
Yes.
Now, is it in full screen?
Yes.
Okay, alright, let's continue. It's wasting my time. Alright. Okay, so anyway, let's continue with where we left last week. So basically, we are now in second week. Uh, let's continue with the describing data. So basically, you guys already understand that the main purpose of statistic is to determine or to take the sample out of the population and make the inference out of it. So from the figure, you guys can see that most of the time researcher cannot, or it's almost impossible to take the whole population to analyze the data. Okay, so from there actually the scientist or researcher, when you are doing your research, you're only gonna take a small sample, and then that's where the experimental design comes, where we need to make sure that the sample that we take is more than enough, is sufficient for us to make an inference for the whole population, right? Okay, so basically, statistic itself can be divided into two main components, which are the descriptive and inferential. So for the descriptive part, we use it to describe about the sample based on their position, okay, central tendency, and then variation. We're gonna go through it one by one, and then for the inferential part, where we gonna learn it, where you guys gonna learn it with Dr. Shamsi in the second half of the semester. Okay, please stop me if I'm moving too fast. All right, so now let's go to the details explanation between the population and the sample. Okay, the population or the number that we use to determine the population also called as a parameter. While for this sample, we use a term of statistic. So that's why we call it as a population parameter. And then for the sample, a sample statistic. It refers to the numerical definition or description of the population and the sample. So population is a complete set, sample is subset. So for the population, the reports are a true representation of opinion, meaning it covers all the population. So for example, reports have a margin of error and confidence interval. This one also we're going to cover in details in the next lecture. All right, the rest all the same. Okay, I just want to use a real study of an example. Okay, so basically, uh, for example, let's say there's one of the company, this one is actually Pfizer. Even when they do their research, when even they have done the research, they're not gonna release all the data. That's one thing. And then the second thing, they cannot test their drugs. In this case is the Paxlovid. I think Malaysia has bought this Paxlovid recently, where it used to treat the COVID-19. And then the Pfizer also has released a study. It's very rare for the company to release a study, but I think because this COVID drug is quite famous, where they need to at least publish excerpt or the simple findings of their experimental design, or we call it as a clinical trial. Okay, so in this case, you guys can see that from the headline, Pfizer's Paxlovid is 89% effective in patient at risk of serious illness, company report. So I've highlighted actually some of the points. When we can go to the next slide. How to disadmit. Okay, so risk of COVID-related hospital admission or death from any cause was 89% lower in the Paxlovid group than the placebo group. Basically, they separate how many samples they have. In this case, I think about 389, or is it 700? I think 700 is a combination of both 389 and 385. So basically, it's about 800, 3, 5, 700, 700 something. Okay, 700 something. Let's go to the real number. I can't remember. Let's assume it's around 700. It's fine. Okay, meaning that the n equal to 700. They didn't do the clinical trial definitely for the whole population. In this case of the study, what do you think would be the population? So basically, Pfizer is trying to study the effects of the Paxlovid drug on treating the COVID. In this case, they did a sampling where they took about 700 samples who got COVID, and then they give there are two different groups. The first one is the drugs, and then the second one is the negative group, which is negative control, which is the placebo. What do you think would be the population of this study?
COVID patients.
Yes, correct. COVID patient. All right. So the sample also COVID patient, but they only take or use about 700 patient. Okay. The percentage here, 0.8%, 0.8% can be also considered as population parameter or sample statistic.
Sample statistic.
Sample statistic, correct? Very good. I can't see who is actually answering. I use one monitor. Previously, I used 3 monitors, but it's so confusing. So I cannot see who is actually answering. But anyway, it's a very good try. Sample statistic. So this number is actually refers to sample statistic. Later we're gonna see another example. Okay, and then in any research paper, you will realize that they always highlighted the statistical significance. This one we're gonna learn. It's very interesting when you know how to read the statistical data. Then you will realize that some study they don't. It is not really significant. Where sometimes they can overclaim about their findings. When you have the knowledge of the statistic, you will realize that some researcher is like try some papers tried usually from under the low impact factor tried to overclaim about their findings. Okay. All right. So another key here or key information that I would like to highlight here is how they did the research. So they highlighted most of the study they will just simply put the name of randomization, where they arrange or assign the patient randomly into two groups. But few I think especially for the higher impact publication, meaning that a high quality journal, they would ask researcher to put what kind of experimental design that they actually use for the study. Is it like a completely randomized design, or is it a completely randomized block design? It's still random, but even the block design is also called random. So the researcher need to be specific what kind of study, because this one they didn't put even the sex into the blocks, so we can assume that they actually just use a CRD or completely randomized design. Any question? Okay, there should be 115 of you. Wow, that's a lot of you. Help me to admit. So annoying like this admit thing. Later I will remove it. Okay, this is the comparison or the symbol used to define the population parameter and also sample design. Okay, for the population parameter in terms of mean, we use the symbol of mu. For the sample, x bar to report the mean. And then the rest is sigma square, and then s square, sigma s, and then the n refers to the sample size. Okay, let's go to the types of data. So basically, when you have done designing your experiment, collect the data, definitely you need to know what type of data that you like to collect. Data types or types of data can be divided into two, which are the qualitative data and also quantitative. Qualitative meaning is categorical. They can further divide it into two, which are the nominal and ordinal. Okay, which do you know what is nominal? Ordinal? Is it the first time that you ever uh, know about this term? Anyone would like to, at least try answer or respond, although it's online session?
First time hearing it.
First time? Okay, it's fine. All right. So basically, this one I would say is not really important, but still crucial for you, especially when you like to visualize your data. But most of the time, especially for biostat students or biological sciences, we covers or we study on the quantitative data. So basically for the qualitative data, for nominal data is actually a categorical data where it can be in term of sex, race, meaning it can be fully divided into categories. Ordinal data is also category, but it can be ranked. You know what is the example for the ordinal data? Such as your grade A, B, C. Okay, now I can write, but I don't know how to erase it. Okay, this one example sex, race, then maybe class, type of class. Then ordinal data, I like to use this example Likert scale. You know what is Likert scale? Yeah, I've explained to the class before. It's like when you like someone, it can be in the range of let's say neutral, uh, usually not like we usually agree, strongly agree. Can you guys see my handwriting?
Yes.
Yes.
Okay, so this one strongly disagree, then strongly disagree. Okay, so meaning that it can be ranked. And then another example is like your grade A, B, C, D. Okay, it's actually ranked. It's category, but it can be ranked. And then let's go to the quantitative data. So for the quantitative data, it can be further divided into two, which are the discrete and continuous. Discrete meaning something that we can count. Is there any additional explanation? But discrete is something that we can count. Okay, for continuous, it's like a continuous data. Usually we cannot count it. All right. For example, eggs. You can count eggs, right? Number of chicken. It's not like infinity or continuous like the continuous data. It's like number of students in this class we can count. There's like 100 of you. There should be 115, but I don't know where's the 15. Okay, number of students. But just let's focus on these three, or we call it also as the level of measurement, the nominal, ordinal, interval and ratio. Okay, for the continuous, there are two under it, which are the interval and ratio. Okay, let's go into details about it. Okay, nominal, this is a simple definition so that you can easily understand it and easily assign or analyze the sample. Okay, so basically for the nominal ordinal, it's very straightforward. Nominal categories ordinals for categorical, then there's a sequence for the ordinal. And then for the interval, it's actually the numerical data. The difference, number two, the difference between two numbers is meaningful, meaning that when you can determine or you can calculate or you can minus the number, the difference in the number is meaningful. This one cannot be done for the nominal and ordinal. And then the most important point is actually there's a non-equal intervals. Okay, number 4, 0 point is completely arbitrary. You know what is arbitrary? Meaning that there's no clear zero. Okay, let's go to the definition of the ratio first before we refer to the some of the example. Okay, ratio is same as interval, but the difference is the intervals can be measurable. And then, can you guys see the slide now?
Yes, but it's not full screen.
Okay, okay, there's an example there. Okay, and then except that it does have a true 0 point. So let's take some example. So how about time? Do you think it is fall under interval or ratio? Let's go to the example one by one.
Ratio.
Ratio. Why do you think it's ratio? Time, weight, temperature. What else? Kelvin. Okay, I think this should be enough. Time. Is it ratio? How about the rest? Why do you think it's a ratio? Anyone would like to try?
Time doesn't have below than that, below than zero.
Say again.
Time doesn't have below than zero.
Time doesn't have below than zero. That's actually a good try. Okay, how about the rest? Let me check. Yeah, okay. Okay, time is actually under the ratio. How about the weight? The main difference between interval and ratio is there's a clear zero for the ratio, and then there's no clear zero for the interval. How about the weight? Is there any zero weight?
Yes.
Okay, so meaning that it is under the ratio. How about the temperature for the Celsius, for the Kelvin?
Ratio.
Why? Because you saw the example earlier. Okay, maybe we go to the Celsius and Fahrenheit. Do you think it's an interval or ratio?
Interval.
Interval.
Why?
There's negative in negative Celsius and Fahrenheit.
Yeah. To understand it easily, you guys can like try to imagine that is there any temperature in 0 degrees? There's still temperature, right? It's still cold, meaning there's still temperature even in Fahrenheit. But in Kelvin, 0 Kelvin, meaning that it is negative 270 degrees Celsius, meaning that there's no temperature at all. Okay, so that's why Kelvin for the temperature falls under the
Ratio.
Ratio.
all right. So make sure you can distinguish between those two, interval and ratio. One thing to easy way to determine it is what I explained earlier. Try to imagine that whether in let's say for example, weight in 0 kilo, is there any weight at all? Okay, if there's not any weight, meaning that it is ratio. All right, clear?
Yes.
All right. Later maybe we can have some quiz so that you can test your understanding. All right, let's go to this one of the example, this one under the discrete and the continuous and also statistic parameter. Let's go through this together. In a survey of 100 students in UPM, 65% said that they have been fully vaccinated against COVID-19. So the question number one is identify the sample and the population. Which one do you think is the sample? Maybe you can try to type it in the chat box. You try to answer, each one of you. Just try. I'll give you like 15 seconds. What is the sample and what is the population? You just answer it briefly. No one answering. Sample, vaccinated student. Population, UPM student. Okay, maybe lah one by one lah. Sample 100 student. Population, UPM student. How about the rest? What you guys doing? You just blank your screen and then just sleep. There's only what 10, 15 of you answering. About 100 of you are here. Oh my god. Sample 100. How about the population? Okay, let's stop it here. This one go through. Sample 100 student, population UPM student, sample vaccinated student. Vaccinated student, how many of them? I mean, you refer to the one that has been vaccinated. This one is too general for sample vaccinated student. Is that the population, of course, is not it's actually UPM student because the study or survey asked about the students in UPM. Then the sample is the number that they use here, 100 students. Population is the students in UPM. Okay. Alright, it's not a vaccinated one because basically the study didn't really asking only the vaccinated. What they did a survey, but they find the student first, only then they asked. It's not referring to the vaccinated students. They didn't distinguish or they didn't discriminate the vaccinated students in the beginning. Okay. All right. Number two, B, is the value of 65% a statistic or parameter? 65% stat or parameter? You guys can type it. Let's do this fast. I don't think you guys gonna stay until 7. Statistic. Yeah, it's statistic because 65% is the sample that the survey used. Okay. The parameter is not parameter. So basically the parameter referring to all the numbers, all of the students in UPM. So see what is the level of measurement of the value of 65%. Nominal, ordinal, interval, ratio. This one can be confusing, but it's still straightforward. You guys try, just type it, or maybe someone would like to say it out loud. You guys also can open the mic, just say it, open your video.
Ratio.
Ratio. How about the rest? Okay, ratio, because 0% meaning zero lah, no student at all. Okay, as easy like that. Okay, are the numbers of subject in such surveys discrete or continuous? Discrete or continuous? Number of subjects.
Discrete.
Discrete, because it's not like weight, it's not like temperature, where it can be numerous. It can be anything. Okay, the responses are yes, no, not sure, or refuse to answer. Are these response quantitative or categorical data? E. Can be confusing to some of you. Yes, no, not sure, or refuse to answer. Are these responses qualitative or quantitative or categorical? Categorical is actually under the ordinal. Okay, very good one. Alright, it's too easy. Alright, let's go to the measure of central tendency, where we use it to find the most common points. Can be true based on the median, mean, and mode. Okay, measure of center is actually the measure center or middle of data set. What is the time now? Can we have like 5 minutes break? Is it
Yes.
okay? 5 minutes,
Yes,
so
okay.
that you guys can have time to digest or rest your mind for a while. Thank you. All right, can we continue?
Yes, doctor.
All right, so let's continue with the measure of center. So mean is the most common type of measure of center that commonly used. Okay, what does it mean by mean? Is the adding all of the data or average values, add all data and divide. Okay, number two, median, the middle value when the original data values are arranged in order. So please remember, some students made a very common mistake about calculating or determining the median when they just arrange the number without putting it in order. So for median, you need to arrange in order first, only then you find the middle value. But if you use SPSS, you can get it straight away. Tomorrow we're gonna learn about how we can use the SPSS to get these numbers. Okay, number three, mode values that occurs with the greatest frequency. Okay, so you can see that the median is commonly used for the skewed data. You know what is skewed data? Later we're gonna go each one, the different type of the binomial distribution. Okay, so for if the data looks like a bell shape, or we call it as the normally distributed, we use mean. So at when it's normally distributed, also mean will be equivalent to the median and also mode. Okay, median, we only use median when the data is skewed. This one is skewed to the left. Okay, and then this, can you guys see my screen or my mouse cursor?
Yes.
Can I? Right. Wait. Wait. Give me. I want to write something. Okay. All right. So I have summarized for you for the difference between measure of center. So for the measure of center, you can use this formula. It's quite straightforward for the mean, even median. So this formula is very useful when you have a lot of numbers. If not, you can, if it is not a lot, actually you can just arrange it and then find the middle. Okay, let's look let's look for some example. Okay, maybe some of you can try to calculate this. What is the means of this number? Someone would like to try? How to calculate this?
3.6.
3.6, correct. It's very easy, right? I don't have to show, right? How about let's continue with the median. How you can determine the median of this number?
Arrange to the
Okay, arrange
ascending
first.
first.
Let's do this together. You need to arrange first in increasing order. So where's the median?
3.
Okay, as easy like that. Okay, actually you can also use a formula, but we don't use it when the number is too small. If this is this odd data, 1, 2, 3, 4, 5. If this is odd data, how many number that we have here? 5. You can use it 5 plus 1, 6, divide by 2, 3. So you count here number 1, data number 1, data number 2, number 3. This one is very useful if we have like more than 10 number of data that is more than 10. Okay, but you need to determine first whether it's odd data or even data. How about the mode? In this case, which one is the mode? This number. Where's the mode?
No.
No, no mode. What does it mean by no mode? Is there any mode here?
No.
No. Why?
There's no number that repeat itself.
Yeah, because basically this is like the number is very different. Okay, it's not the same. So there's no like repeating number. Okay, that's good. At least you like revising what you have learned. I think you have learned this in your matrix or in your foundation. Okay, so for mean, usually we use for continuous data, especially for the normally distributed data, median for the skewed data, mode for the categorical. Okay, mean is very sensitive to outliers, but doesn't apply to the median and mode. Okay, if let's say if the data is multimodal, this one we call it as multimodal, meaning there are more than one peak. In this case, you need to report the mean, median, and mode, meaning you need to report everything lah. Okay, when you encounter this kind of data, you need to report all three: mean, median, mode. But if it is normally distributed, you should use only mean, and then of course the mode. If it is not, you only if it is not normally distributed, you use median and mode. Okay, let's test your understanding. What is this type of data or type of distribution? Is it normal?
Normal
Is it
distributed.
normally distributed? Okay, we call it as a Bayesian or also normally distributed data. Later we're gonna learn in detail what does it mean by normally distributed. What we are trying to do actually. We're gonna learn it in the sampling, where you will realize that how important is the bell-shaped data or normally distributed data. Okay, how about this one? Is this positive or negatively skewed? Someone? Or maybe you guys never encountered this, but anyway, let's do this together. This is actually positively skewed. You're gonna get very confused about this, because anyway you can see that most of the data is actually at the left, meaning it is at the lowest. Okay, but considered as positive. Why? I also don't know why. So anyway, we consider this data as positively skewed. If you guys would like to remember this, just see, look at your toe. So you can see that your toe is like this, right? At the right hand side, right hand toe, and then left hand toe. So for you to easily remember this, positively skewed data is your right hand toe, and then negatively skewed data is your left hand toe. Okay, clear? How about this one? This one is like normally distributed, but it has a like unique characteristic of sharp point. This one multimodal. Okay, this one. Okay, let's try again. Your understanding the one that I have explained earlier. Which one is positively skewed?
C.
C.
E. There's no E here.
C.
Positive. Negative.
A.
A.
Okay, what does it mean by negatively skewed data? If normally distributed or normally distributed data, the data focus at the center, or we can get the data mostly distributed in the center. How about negatively skewed data? The data is like how we get what can we describe about the data? Most of the data can be found. Most of the data can be found at the
Right side.
say again.
Right side.
I can't hear you clearly. X side,
Right side, doctor.
right side. Okay, right side. Okay, right side, correct. And also it's actually at the high number or positively numbered, meaning it's if let's say we use an example of weight, if let's say the average weight of these members of this class is 100. Oh, the average, wow, you guys are very heavy, 100 kilo. And then this one, maybe 50, 150. If let's say the number of students in this class is many of you, 100 lah kan? 100. Okay. Maybe, okay, if it is normally distributed, we can say that about 68% of you falls under the plus minus 1 standard deviation. But anyway, this one we're gonna cover later. But I think maybe we continue for the other notes first, other slides first. Okay. I think I'm gonna make you guys confused. Alright, any question about this? Okay, can proceed.
Yes.
Okay, let's go to the which one? Position and the variation or dispersion. So position, we use the measure of position to know the location and then compare the relative between other numbers or other sample. And then for the variation, we want to see how spread of the data, how spread of the scores looks like. Okay, dispersion or variation can be further divided into three, which are the variance, standard deviation, and also range. Okay, let's go to a little bit of the definition, a simple definition for you to remember. Range is actually a measure of spread over 100% of data. Number two, variance, average squared deviation of values from their mean. Later, we're going to see the difference between, what does it mean by the standard deviation, variance? Standard deviation, average deviation values from their mean, and then coefficient of variation, ratio of sample standard deviation to sample mean multiplied by 100. Okay. The coefficient of variation is just the ratio, meaning that you use the standard deviation and divide by the sample mean and then times 100. Is there any question here? All right, measure of position. This one is quite straightforward. Usually we use 5. Okay, five numbers actually. 5 percentile, 5 different percentile, usually the most common one. So, why I cannot write? How to erase this? Okay. Q1, Q2, Q3, Q4. You familiar with this quartile system? Q1 refers to, my God, cannot write. 25th percentile. Q2, 50th, or also known as median. This one is actually arranged. We need to put arrange in order. Only then you can determine the quartile. Q3, at which percentile?
75.
25 percentile. Q4, usually there's no Q4, but for the journal, usually it's the range Q3, Q4. They call it as the 75 to 100 lah. Position. So this is the position. Okay. Alright, IQR. Interquartile range. You can just determine it by dividing Q3 to Q1. Okay, this is the summary. I put it in summary so that you guys can easily understand it or visualize it or even study, because the earlier slide, the slides that I got actually from the other lecture is very complicated. So I would like to make the students' life easier so that you guys can use it as your note. Okay, so range, how to determine range? So it's actually the maximum divided by minimum. Wait, okay, then let's go to the variance. This is the formula. You guys familiar with this formula, right? Later we're gonna have like an assignment for you guys to do. So and then you need to submit. Later we go through that part. Okay, standard deviation. Okay, then just to take note that there's a different. The formula is still the same. It's actually the symbol that used to describe the variance is, this one is sigma squared, and then this one S squared. S squared refers to sample or population.
Sample.
Now this one refer to as sample statistic. This one population parameter. Same goes to this sigma S. Especially the SD, I think you guys are quite familiar with it. The SD is actually the square root of these variance. Then coefficient of variation, SD over mean is what I've highlighted earlier. So when we to use COV or coefficient of variation, it is good when comparing variation between groups. Okay, percentile is fine. We have gone through IQR. So this for the measure of variation or position, the one that really sensitive to outliers are three, which are range, variance, and standard deviation. Okay, maybe some of you got confused, or maybe they are like in the zone and forgot about the principle of the standard deviation, and then why most of the data or even the publication, scientists will put the standard deviation, because we want to know how deviate the data from the mean. Okay, if the data is too varied, there might be some really scientists assume that there's actually another other factors that might be influencing the findings. Okay, that's one of it. Then usually this is also one of the parameters that we use for the determination of the confidence of determining the whether that data is statistically significant or not. Okay, so basically from here, because from the we gonna learn about the confidence interval, so we gonna see how the standard deviation is very important to see. How the deviation of data can be very important parameters to be used. Okay, so for this one, okay, from here I think it's very clear that this picture shows that when you have determined your mean, then when you take your data, most of the time your data not necessarily the same or close to your mean. It can be deviated. So the observed value, if let's say you have 10 samples, if let's say you are sampling the weight of the students in this class, it might be deviated. It's not necessarily even the mean is 100. Doesn't mean that the weight of all students is close to 100. It can be either 110, so let's say. Oh, there's a eraser there. 110, let's say this one 90, this one too close, 80, 130, 140, okay, 75. You understand what I'm trying to say, right? So basically, this data or the standard deviation, we like to see the spread of the data from the average or from the sample mean. Is it clear why we use standard deviation? What's the function of standard deviation? Any question?
Can you explain it again?
Which one? Which part?
The deviation part.
The deviation part. Okay. Alright. So basically, the standard deviation we use to see how spread are the data from the sample mean. Okay, that's why the formula here, you guys can see the formula is x1 minus x bar. S bar is the sample mean, and then S bar is your observed value. Okay, maybe let's use some example from the chicken. Okay, maybe I'll just write study on probiotics on chicken. I want to study of probiotics on chicken weight. Treatment one is negative control. Then treatment 2 is the probiotic. And then you have like, maybe for the sake of simplicity, maybe we use 10 sample, 10 chickens. And then let's say for the probiotic group, for the 35-day-old chicken, usually they are range, this one 35-day. The average, of course, we would like to see that the probiotics is giving a good result in terms of their weight, so then we can sell it much more expensive in terms of weight compared to the negative control. And then probiotics is truly or provenly beneficial to the chicken in terms of improving their health and also chicken weight. Okay, if let's say the average weight after 35-day study, this probiotics is given daily. So that's maybe 2.3 kilo, the average out of 10 chicken. Then the control maybe 2.1 kilo. You have 10 chicken. Okay, this is the average mean. The average or the mean is 2.3 kilo, meaning this is the X bar. You have 10. If let's say, just put S1, S2, S3, S4, until 10 lah. Okay, not necessarily that all the sample or all the chicken weight would be at 2.3 kilo. This is your average. Definitely some would be maybe here, some can be very close, some can be very far, some can be so be close, some can be far away. Usually some scientists or researcher will remove this, but it's actually not good. It is not ethical to remove any number of sample if it is showing a strange result, because there might be a reason why it is deviate so much compared to your average. Okay, is it clear? Or do you want to have more explanation on this?
Yeah, doctor. Thank you.
Yeah. Later you can see why this deviation can be very important in terms of determining the confidence interval. Okay, let's go to the data presentation. This today's lecture is actually quite simple, very straightforward. I think you guys have already an understanding or the basic about the describing data. So let's go to the next part, data presentation. Okay, there are 4 different kind of visual presentation that scientists or researchers use. The first one, bar graph. It is very useful for the categorical data. Okay, categorical meaning can be either nominal or ordinal. Pie chart is very useful for the categorical data, mostly nominal. It's very, it is not suitable to be used for ordinal because it's ranked. Okay, it's not suitable for ordinal. Then for the histogram, we use for the continuous data. What does it mean by continuous data? You guys remember? Can we further divide it into 2, which are?
Interval and ratio.
Yeah, very good. Interval and ratio. You can use to display shape of data distribution. This is where we get the normally distributed data. It's actually from the histogram. Okay, usually The simple version is just the, wait, what's wrong with this? It actually comes from the histogram for the normally distributed data. This one we're gonna learn on sampling distribution. Okay. Shows data spread, identify outliers. Okay, box plot. So for continuous data, good for comparing between data set, usually between different groups. Display shape of data distribution, location of center, and data spread. You also can use it to identify outliers. The most common or the best way of determining outliers is actually through box plot. Later we're gonna learn about the five number summary, how to determine the outliers. Okay, this is just the way of visualizing the data. Again, remember that the bar chart always very useful for categorical, can be both nominal and ordinal. But it is not suitable actually for to use pie chart for the ordinal. But I don't know why they put it here. Okay. Some scientists will argue that the best to describe ordinal data, like your result, grade, everything, will be from the bar chart where you guys can see it clearly. Okay, this one for categorical for the microbes. Okay, you know how to construct a box plot? Have you guys have any experience doing this? Anyone? Have you learned it in your matrix? No. Anyone?
No.
No.
Okay, let's learn this together. Okay. So the box plot, how does the box plot looks like? This is the box plot. Okay, and then this is the center. Let's me second should be median, yes, median. Q1, Q2, of course, median, Q3. Then this is like they call it as a maximum, minimum. Okay, we have a formula actually to calculate this. Let's go through one by one. So how to construct a box plot? First, you need to find the five number summary. What is the five number summary? Later we'll go through. Number two, construct a line segment extending from the minimum to maximum. Number three, construct a box extending from Q1 to Q3. Then number four, draw a line. Let's go through some of the example. Okay, median, like I think I've drawn earlier. Median refers to actually Q2. Here, Q2. Quartiles, Q1 and Q3. So meaning that first you just draw a box, extend a line. This one later we're gonna determine. You need to determine how long it should be. But definitely, if the box, the first the left the left end of the box will be the Q1, and the median will be in the middle. Then the right end is the Q3. Min max. So I don't have to draw one. So the box is already there. Okay, so how to actually determine the minimum and maximum? This is the formula. You can calculate it through Q1. Okay, first we need to determine the Q1. You know how to determine Q1, Q2, Q3, right? The one that we have learned earlier. 25th, 50th, 75th. So meaning that you need to arrange and then you need to determine the percentile, the data that falls under that percentile. Okay, for IQR, the formula is Q3 minus Q1. This is actually the five number summary. Q1, Q2, Q3, IQR, and then 1.5 times IQR. Okay, clear about this? Am I moving too fast? You almost finished. Any question?
No, so far
That's it.
clear.
Okay, clear. It's okay. For those who are shy, or maybe you can ask tomorrow. We still gonna meet tomorrow morning. Let's finish this first. Okay, how to handle outliers? Okay, so there are many reasons outliers can be found in your data. If the outlier is legitimate, usually we not usually you cannot discard it at all. You cannot. It is not ethical actually. There's some students or even my colleague last time. He likes or he or she likes to remove if the data is really uh, far away from the mean, meaning that it's deviating so much. One thing that you can do in that situation is actually you can just repeat the experiment, but don't simply remove the data and then just add a new data that add a new artificial data. Artificial meaning is like you didn't do it at all. You just beautify the data by just putting a number that close to your mean. Okay. Most of the time, we repeat the experiment. But if the study or the data is too big or too large, usually this is what we're gonna do. If they legitimate, we maintain it. If it is due to human error, it should be discarded. Okay, but it is very rare for us to determine whether it is human error or not. Usually, we just repeat it. Very rare in terms of we maintain the data. Sorry, it should be to discard the data. We repeat it again, but maybe in the situation when the data is too large, and then the experiment only can be done one time, especially when it involves animal or human clinical trial. Okay, number three, individual in question belongs to a different group than the bulk of individuals measured. Okay, what you can do is values may be discarded if a summary is desired and reported for the majority group only. What does it mean? Meaning that they misplace or the data should be in other group, but it's actually put under a different group. Okay, in this situation, the data can be discarded if a summary is desired. Okay, clear? All right. So we gonna move into some activity before 7. Before we go to this, can you guys see my screen?
Yes.
Not the slide. Alamak, I don't answer. Wait ah. This one a quick one. This one is try to open this link. Let's do this together. Or maybe you can use your mobile phone to scan the QR code from mobile device. This one like a short quiz for this lecture on describing data. Can you guys join? just for fun. Okay, I'll give you guys another 30 seconds before we start. You guys can still join even if you have start. Okay. So let's start. It's been some time since I used it. Just need to determine which one is the suitable one. What is this continuous order equal meaningful zero? It's a ratio meaningful zero. The key is meaningful zero. Right, let's go to the next one. There's still some. There's not some. A lot of you answer wrongly. It's actually interval data. Okay. If you guys still confused, maybe you can ask me again to explain tomorrow. It's almost 7. Let's do it fast. So very easy. Let's see, still some a few or a lot of you still got wrong. But anyway, to be specific, it should be ordinal certain categories. Is it continuous, parametric? No, I mean maybe I didn't cover on parametric because the syllabus didn't really cover in details on parametric. But it's actually not parametric. Parametric should be continuous data. But anyway, it's fine. Average value. Let's get all correct. Dia juga salah tu. Average value. Average value definitely no. It's not mean. It's not. It's not median. It's not mode. Average value is mean. What? But it falls under the measure of center. We are trying to determine the center, and then it can be further divided into 3: mean, mode, median. But the definition of mean is actually average value, not the median. Median is the center of the data. There's still one question. Okay, let's go. Let's do this fast. There's still another 6 question. If you have any question, you can ask that later. Okay, nominal. I'll spread out the data is and now it's first one. Standard deviation easy. The value that occur most frequently. So ni jawapan. easy. What kind of question lah? Ada juga salah tu. If the data is skewed, it is better to select the median. In this case, what does it mean? Why the data is skewed? Outlier, not outliner. It should be outlier. Outliner. This one I just got from the some other people who submitted. But I think you get the point. You should get the point. Discrete data. Non-parametric test. Still two more question. No, outliner is why like this guys. Outliers. Q. Should be skew. The value in the middle. The median. Oh, I give the answer. The question is very easy. So it's fine just to strengthen your understanding. Okay, should be median lah. Highest or the lowest. Hello? Can you guys hear me?
Yes, doctor.
Okay, alright. Cannot hear any sound. Is this the scoreboard? The leaderboard? Who is three meaning three only cracks huh? Oh no lah.
No,
No, number one meaning but they
they share
cannot see
the
the
same
score.
number one. Yeah.
Oh, there's a lot of you number one. Wow. But I want to see how many cracks. Okay, congrats to number 1, 2, 3 SBS. I don't know why you guys didn't use your full name. So anyway, congrats. Alright, so I think let's end the lecture for today. You guys, we're still gonna meet tomorrow, and then don't forget. I think it is best to bring your laptop, okay, for tomorrow's class, so that we can. If you have any issue with the installation, have you guys sent the request to install the SPSS to the IDEC UPM?
Done.
Haven't yet. I think you should. If you haven't done yet, maybe we do it together tomorrow. Oh, attendance. Okay, I forgot about attendance. Let me check. I thought I've removed the password. Is there still any? Is the password still there? So already open, right? What you guys? The password. Let me turn off the password. Oh my god. Okay, you guys can fill in your attendance. No need password, everything. You just fill in it. Alright, any more questions you guys can ask tomorrow? Alright. Thank you very much.
Thank you, doctor.
Thank you, Doctor.
Thanks tomorrow.
See you tomorrow, Doctor.
Thank you,
Alright,
doctor.
okay.
Thank you,
Student
doctor.
to come early. Bye. Thank you. Yes. 8:30, not so early. Alright, still have time. Alright, thank you.
Doctor,
Yes,
can you upload the notes because some of it is missing.
some of it.
Yeah,
Okay,
like some of the diagrams.
okay, no problem. I will upload the revised one. Thank you. Bye bye.